Yes. Ah,
Yes.
okay, good. Fine. Now there is a right. So all of you have okay. Victoria, we might need to just modify this statement a little bit. Okay. Uh, so let me just get that number.
Okay, Professor.
1 second. So yeah. Okay. So all of you have this chip called CD40106B.
Yes, sir.
Yes, sir.
Okay. So the experiment 3 actually is very straightforward. Okay. At least on the face of it, it appears like this. Configure your counter 74LS163 to count up from all zeros to all ones. Okay. Explain how it can be used to check the functionality of a 4-input combinational logic. Okay. Pin connections I have given you like this. Right. Now the only catch is this will not work. Okay, so I first want you to try it as it is described here. Okay, and see what happens. Okay, then you got to use this CD40106B appropriately in the path. Okay, I'm not going to tell you where to use it. You got to tell me what actually, no, maybe I'll tell you where to use it. You have to put it between your ADLM ALM kit and the clock input of your. So you see the pin connections, right? Give a clock to the CLK pin of the IC from the ADALM kit for 100 hertz, right? What you need to do is you need to give, instead of to this clock pin directly of 7416 LS163, give it to this CD40106B chip. Take the out of that and give it to the counter IC. Okay. Is that clear?
Yes, sir.
Okay. So
Yes, sir.
this is what you have to try. Okay, what's going to happen is your ADALM kit will not be able to drive the 74163 sufficiently. So this chip, other chip is a buffer chip that is going to help you drive this counter properly. Okay. Have any of you tried it?
Yes, sir. I tried.
What did you observe?
Sir, basically, I am not, like I am using only Adlam kit for giving the pulse, but it failed.
It failed,
So,
right?
yeah.
Now take the same thing and put this chip in between. You
Okay.
understand? So this
Yes,
CD40106, look at the data sheet. Hey, Vivek, can you just open the data sheet of this CD40106?
Yes, sir. I've opened it.
No, this is 163. I'm talking of CD40106. You'll have to search on Google. CD40106 data sheet, yeah. So you see what is given here? Go down. Pin 3, 5, 9, 11, 13 are inputs. Okay, 2, 4, 8, 10, 12 are outputs. Okay, 1, 3, 5, 9, 11, 13 are inputs. 2, 4, 8, 10, 12. So choose any combination. You can choose 1 and 2. Go down. Down. Further. Here. Right? You can choose pin 1 and 2, for example. So connect ground to 7, VDD to 14, and then connect your input to the pin number 1 from the ADALM kit. Take the output from pin number 2 and give it to your 74LS163. See if it works.
Sir, so this chip just converts the analog signals to digital.
No, it does not. It is not an analog signal to this thing. But that's why I'm saying first I want you to try. then I will tell you the answer. Because if I tell you the answer without you trying, you will not even appreciate what I'm saying.
Yeah. Okay, sir.
Okay, all of you try this. Then next Monday, I will tell you, I will explain why this is happening and what this chip is actually doing in between. Is that clear?
Yes, sir.
Okay. Any questions?
Sir,
Yeah.
sir, can we do this experiment without this chip using 555 IC to give clock
Yes.
pulse? Is it okay?
Yes. Yes. That's also okay. You can do it that way also. There is also a way to program the kit to give you a clock from the digital outputs. Okay.
Okay.
That code also I will share with you people. Either this CD104, that route you should be able to generate a clock, or you can generate with 555. I'm okay with anything.
Okay, sir. Basically, this is my doubt. I tried and unable to get the desired result.
No, no, in what?
Like, sir, counter does not work
No, no,
perfectly using
you tried generating the clock with what?
only Adlam.
Only IDLM will not work. That's what I'm telling
Yeah,
you.
yeah, yeah,
Okay, so you try this. This is the I would say, in my opinion, the biggest learning from this lab.
okay.
Logically, everything is correct, right? If you look at the pulse that's coming out of Adlam kit, it looks correct only, no?
Yeah, yeah.
The clock voltage waveform is correct. Then why is it not working? That's what you have to learn. Okay. So
Yes,
try
sir.
this first. Try this and let me know.
Yes, sir.
Right? Okay.
Yes,
Any
sir.
other questions? Actually,
So
we
good
can.
evening, sir.
Yes.
So for the countdown, also we'll have to use the NOT gates of this IC.
Yeah. Countdown. You can try. I don't know if I don't know if the counter itself can count down. Can you check that? Vivek, 74163. Go to the data sheet of 74163.
Yes, sir. Sir, it's here only, right?
Yeah, yeah, yeah. You have it. Yeah. So this can count down, right? I don't remember. Up, down. Is it there?
I think this is for, yeah, LS163.
No, synchronous counter. Does it say up, down counter? That's my question. Go down, go down. Direction. I don't think there's a direction, right? Yeah, I don't think there's a direction. Okay, actually, forget the down counting. I'm okay if you don't do the down counting because that's just a logical thing. If you put inverters, it'll solve that problem. Okay,
Sir,
we are not here to do logic simulation like things here. Okay,
Sure, sir.
don't worry
sir,
about down counting.
this IC only generate up counter.
Yeah,
For
yeah.
down
So
counter.
don't worry about down counting then. Forget it.
Okay, okay.
That's a trivial thing. I'm not interested in that. Okay, I'd rather have you spend time on generating the clock. Okay. Actually, Victoria, can you do one thing? Uh, Hello, Victoria, are you there? One second. I don't know why. What happened? Wait.
Sir, your voice is coming.
Yeah, yeah. I know. I'm not. I don't know where she is because what I want to do is I want her to set up this meeting tomorrow so that you can try the experiment and then we can talk tomorrow. One downstairs. Yeah, one second. Okay, someone had a question. Yeah, someone had a question. Sorry?
Sir, in the previous experiment, I faced some difficulty, like sir, to generate AC and DC both, sir, from ADLM kit, sir.
Why?
I'm not understanding how to do this, sir. AC,
What?
AC along with DC, sir.
No. What is the problem? I don't understand. So, what was the experiment?
Previous experiment regarding, sir, wheat store wheat experiment, sir. Initially, I have given 2.5 volts, sir,
Yeah.
and measured corresponding node voltage at A and B and V out voltage, sir. Later, sir, in the next problem, it is given to supply an AC voltage along with DC voltage, sir. There I stuck, sir. I'm not understanding how to
No.
do
What do you mean? You came for the electronics systems thinking course, no? Lab.
Yes, sir. Yes,
Then
sir.
he showed you how to whatever ADLM is generating is an AC over a DC only, no?
Okay, okay.
What do you mean? I don't understand. That's the only signal that is generated by ADLM.
Okay.
It does not generate a pure sinusoid. It is a sinusoid over a DC always.
Yes.
Okay. Yeah. Victoria, are you back? A second. Hello. Yeah. Hey, can you ask Victoria to join the call there? I think is she on the call or not? The Yeah. Any other questions?
Sir,
Yeah.
that component list we have only received only two LEDs,
You mean
and this two
seven
LEDs,
two 7-segment displays or two LEDs?
two LEDs. For this
Okay.
experiment, I guess we need four LEDs. So, is
No,
there any way to
no,
check?
you can even do it with two LEDs, right? You just look at the frequency with which it changes, you'll know. Do it two at a time.
Okay.
Okay, the other thing is to simply look at the output waveform QA, QB, QC, QD, feed it back to the this thing to the ADALM kit and view it on the oscilloscope there.
Okay, sir.
Put it back to channel B. That's what I'm saying. Okay, and ultimately you must look at the frequency of these waves, right? That's all that matters.
Okay, thank you, sir. Thank you.
Okay, yeah. Yeah, Victoria, are you back?
So I had one more question.
Yes.
So for the point number 3, where we have to give a logic for validating any combinational 4-input circuit, So, what is the expectation? What is the explanation that we need to give over there? This is mentioned in the assignment point number 3.
No. Okay, sorry, I was on mute. Sorry. I'm saying, how do you verify if a combinational block with 4 inputs is correct or not?
So any combinational block using this particular IC 163, we need to justify how we can use this IC.
No,
to
forget
verify.
163. I give you a combinational block with 4 inputs. What should you do to make sure that it is functioning correctly?
So the combinational block can be, sir, anything. It can have any combination of gates, and
Yeah, it can be anything, right? It can be any
Right.
truth table that it can take 4 inputs and any number of outputs.
right.
Possible if you have 4 inputs. Now tell me how many input combinations are possible? Oh,
Okay.
16, sir. With
16.
4 inputs, 16 combinations possible, sir.
16 combinations. Now,
Yeah.
if you can guarantee for 16 combinations, the circuit is functioning correctly, you are done, right? You agree with me?
So
Correct.
if for 16 combinations, sir, we are getting some output, then that means that we have validated that for the 16 combinations we are getting, it's working, the circuit.
Correct. So, question is,
Okay.
how do you use this counter to actually do that in one shot? That's all. That's why I will leave it at this. Okay. So, Victoria,
Okay, sir.
please, are you there?
Yes,
Sir, it was-
Professor. Yes,
Yeah.
Professor.
Please schedule another meeting tomorrow at 4:30.
Okay, Professor.
Okay, because I want them to try this experiment and come back to me.
Okay, Professor.
Okay, yeah.
Yeah, Professor.
So all of you, we will meet tomorrow at 4:30 because I want you to try the experiment by using that CD10406 whatever chip, and then come back to me with what you're observing. Okay,
Oh, yes, sir.
I don't want to
Excuse me,
wait.
sir. I had a small doubt.
Yes.
The clock input that we are giving with our IC555 timer, can we replicate that clock input from from a Python code itself?
Yes. Yeah, you can do that from the digital out of the ADALM kit.
Correct. So, sir, what do you recommend? Should we use the the IC, or should we
I say
do it the other way?
I said, no, you should try it with the IC because that is where your learning is. Then, as
Correct.
up, you figure out how to do it with 555, you do it with all the other things, with the Python code, whatever.
Yes.
Okay.
And I believe if you want to do it with the IC, we also need a capacitor. From what I researched, so that capacitor needs to be the value needs to be more than 4.7 microfarad.
No, for which IC?
Sir, 555.
No, for 555, that's a different story. But for the CD 40106B, you don't need capacitor.
Okay, I think I had the very same IC that was given in the question.
No. See, there are two things. I think you missed the first part. The question description that is given to you involves only 74LS163. where
Correct.
the ALM kit is driving that 74LS163 directly.
Yeah.
It won't work. You have to think why it is not working. Then I said, put this CD. You see the other data sheet that Vivek has opened, CD 40106B. The other tab. Switch to the other tab. This chip is also given to you. CD 40106B. Now insert this chip between your AD-ALM kit and your clock input of 74LS163. Okay. And see what happens. Explain what is happening. That is what we will discuss tomorrow. Okay.
All right, sir. Got it.
Yeah, fine. Okay, so I think we can close for today. I want you people to please try this experiment and come back to me tomorrow. Okay. So that's all.
Yes, sir.
So in between, in this pin connection, all I am saying is the additional statement that needs to be added is connect the AD-ALM clock to that CD 40106 pin number 1. Take pin number 2 output and connect it to the clock of the 74LS163. Okay?
Okay, sir. Okay, sir.
Right? Okay. So please try this and then come to me tomorrow with doubts. I will clarify all your doubts tomorrow.
Okay, sir.
Okay?
Sure, sir. Sure, sir.
Yeah. Okay. Bye.
Thank you, sir.
Thank
Bye.
you, sir.
Thank you, sir.
Thank you, sir.